If the coefficient of static friction at points A and B is 0.3, determine the maximum force that can be applied without causing the spool to move. Let's draw the free body diagram. So we're going to have a normal force at B. We have a friction force at B. If it's going to rotate this way, the frictional force is that way. I'll call that FB. And FB is going to be equal to 0.3 NB. We also have a normal force at A and a friction force at A, which will also be up. And FA is also equal to 0.3 NA. And we have mg down, which is 100 times 9.81, or 981. Going down, it's kind of hard to see in there. So let's sum the forces in the x direction. In the x direction, we have the force of friction over 0.3 and it be. We've got NA over, so we'll call this one negative, this one positive, and that equals 0. So NA is equal to 0.3 NB. Sum the forces in the y. Negative 981 plus P plus NB plus FA. Equals 0. So for FA, we can put in 0.3 NA, and into that we can put in 0.3, so that's 0.09 NB. Okay, now combining these two, we have, and moving 981 to the other side, we have 981 equals P plus 1.09 NB. Now we still have two unknowns. We need another equation, so we'll sum the moments about the center of the spool. I'll call that C. And so we have P times 0.6, which will cause rotation that way, which is positive. And then we subtract off NB goes through it, and A goes through it, FB. So minus 0.3 NB times this distance, 0.9, is the outer radius. The inner radius was 0.6, which just applied to the P. Minus FA, which is 0.3 NA, times 0.9 also. Now, in for NA, I'm going to put 0.3 NB, and so this becomes 0.3 times 0.3 NB times 0.9 equals 0 there. And so if I do, say, 0.6, I'll move these to the other side, or that other side. So 0.6P equals 0.27 NB plus 0.081 NB, and P equals 0.585 NB. I'll put this into there, which gives me 981 equals 0.585 NB plus 1.09 NB, and NB equals 586, and P equals 0.585 times 586, which equals 343 newtons.